Okay, today we're going to be looking at day, let's see here, what is it here? 8, I think. No, day 7. And we're going to be looking at 2 triangle problems. We'll see how it goes with the time, but we might break this into, I'm thinking, 2 parts, a drawing part and a word problem part is probably what will happen. And this is solving problems. Okay, and that'll be both drawings and word problems. I think we'll probably break it into 2 parts because it can be complex area because there's with more than one right triangle. All right. So that's basically what we're going to look at. And we're going to look at examples of drawn triangles. Finding a missing side or angle. Okay, that'll be the first part. I think we'll probably do it in 2 parts rather than 1 part because it's fairly chunky here. So let's start with the first example. And that will be finding missing length. Let's go calculate the length of xy. In the following diagram. Now, thing with this type of a problem is you're going to end up having a couple of different ways to solve it most of the time because you might start in a different area. So let me draw the double triangle here, a common one here. So here's my base there. Make a little triangle like that, and then slice it here. Often you'll see one like that, and they'll say that this one here, let's go, this one here is X, and this one's Y. And this is not necessarily a right one. And this one here is Z. And they say this is 20 degrees here. This is 22 degrees here. Okay. They say that this is a right triangle on both sides there. And this hypotenuse here is 8.4 centimeters. Okay. So basically what we want to do here is we want to find xy. So we want to find the missing common side and then take that common side and find the hypotenuse. So there's 2 basic steps in here, and we'll just slide this right to the top so we can see it a little better. Okay, so let's do it in blue here. So I'm going to label this one. We don't have, I should put a W there. Okay, so first step is find YW. Okay, this here common side. And like that. Okay, so if we're going to find that common side, we are going to be using angle Z. Angle Z said 20, so that's opposite over hypotenuse. So the sine of 20 degrees equals x, or YW, pardon me, not x, over 8.4. So we're going to multiply both sides by 8.4 to get our result. Okay, that's going to cancel it out here. Take your calculator out, okay, and go 20, or sine 20. Make sure your calculator's in degrees, obviously. Okay, I get 0.342, and then what I'm going to do is I'm going to go times that by the hypotenuse, 8.4, and I get 2.87. And I'm going to keep an extra decimal for now. I'm going to say that YW equals 2.87 centimeters. Okay, normally you'd round off to a tenth or whatever, but I'm going to keep it extra because we have a second step. So now that I know that this equals 2.87 centimeters, I'm going to be looking to get XY now. So we're going to be using this angle 22. So this ends up being the adjacent side. So we'll use a different color so we don't get confused here. Okay, so this is the adjacent side for the 22-degree angle, and this is the hypotenuse side for the 22-degree angle when we're using the smaller triangle here. So we can see that adjacent and hypotenuse is cosine. So we can say that that's cosine of 22 degrees is equal to 2.87 centimeters, which we just found out, divided by h, the hypotenuse. Okay, or in our case, we can say yx or xy, which we probably should. Make that skinny again, because that's what we're trying to find. Okay, now that we have it, so we've got, okay, well, we've got to get rid of the xy on the bottom on both sides. So we've got to multiply it out so that we got it by its off the bottom. Now we can just divide by the cosine of 22 degrees on both sides. Actually, I should do that in a different step so it's not so full of things there. So we'll do that. And it's xy times the cosine of 22 degrees equals 2.87. Okay, now I can divide cosine 22. Okay, so that leaves me with my answer that I'm looking for. Now we can round it to the nearest tenth. Okay, so we're going to go, what is the cosine of 22? That is 0.927. Okay, 1, 2, I guess if I round it off. So when I divide that out, okay, 2.87 divided by 0.9272, I get 3.095 or 3.1. Okay, so there's our first example of finding a double triangle problem where we're finding a side. So we're dealing with a common side, which is a common way of having that problem. Okay, so let's do another example here of a different kind of a shaped one, and then I'll give you maybe one to try. Like I said, I'm going to probably split this one into two different problem day or two different instructional days so that we can keep the video under half an hour for both days, because we also have to do word problems as well here. Okay, so let's take another look at a second example of a drawing. Okay, so another type of example that you'll get is a right triangle with two top end hypotenusae on it. So something that looks like this. So this would be like, there's about 4 or 5 different kinds here, but we're going to look, well, actually there's about 3 or 4 different kinds. So we've done the two right triangles beside each other. Let's do two right triangles, one over top of each other. So let's say we have this type of a setup. Okay, we've got a right triangle like this. Okay, and then what we sometimes see is one over the other like this kind of a setup where we have one triangle inside of another, so that this is our right triangle here, and they label this one whatever X, let's just call it, let's just call it X, ABC, we'll go ABC, that'll be easy, A, B, C, and we'll call this one D, and we're going to say find D, B to the nearest tenth. Okay, and let's say that they tell you that this one here is, I don't know, let's say that this is 10 centimeters, 10.5 centimeters, and that oh sorry, not DB, AB. DB is a common side, sorry guys. I'm looking at my diagram here on the side and I find AB. And let's say that this one here is 4.4 centimeters, and this one here is, looks about the same, but we'll say it's slightly shorter. Let's say it's 4.0 centimeters. Okay, and you want to find dB. Okay, so we have to kind of find this here, AB side. So you can see that this is a big right triangle, but we kind of need to find out, this is not a right triangle in here, so we kind of have to find out what these angles are in the triangle, like the top angle here, so that we can find this angle here and that one there. So we can find angle A, okay, by looking at adding up this side and finding what it is, because this is a right triangle if you look at ABC. So in triangle ABC, this here would be, let's use a different color here. Let's say that this would be our opposite side, and this would be our adjacent side. So we can find angle A first. Okay, so we're going to go angle A in this case is going to be tan of A, because we're looking at opposite over adjacent. So that's going to be 10.5 centimeters over, you have to add these two together, 8.4 centimeters. Okay, do our division. Okay, take your calculator out, go 10.5 divided by 8.4, 1.25. Okay, we'll do inverse tan. Okay. And I get 51.3 degrees. Okay, so there's my angle on the top. Okay, And then I want to find, okay, so now that I want to find AB, so now that I've got an angle, I can now find the hypotenuse. I guess we could just use Pythagorean theorem there too. So whatever, that would have worked too. So now I can find this angle here, or this side here, by using that angle again. So I'm going to go, this time I'm going to use the 51.3. It's going to be opposite over hypotenuse. So that's sine of 51.3 degrees is going to equal, okay, opposite over hypotenuse, 10.5 over h, which is our AB that we're trying to find. Okay, so now that I've got the AB there, I got to multiply it out. I never even thought we could just use Pythagorean theorem there, but you could, but that's okay. I wanted to kind of show the double triangle this way anyway. Okay, so now that I've got that AB times the sine of 51.3 degrees equals 10.5, we're just going to divide out the sine. Okay, and then we'll do one more example, I think. Okay, so let's divide it out. So this gets us 10.5 divided by 10.5 divided by sine 51.3. I get 13.5. And again, like I said, you probably could have just used Pythagorean theorem there. It would have been quicker and shorter, but that I'm kind of using the sine and cosine angles. Okay, there's one more drawing that they do here, where they have kind of an oblong rectangle one. So there's a third type here. There's the layered one. So we'll do one more, and because we're already at about 18 minutes here, so I don't want to go too much longer. Oops. All right, so we'll flip the page here, and I'm going to draw a kind of an oblong rectangle, something that looks like this. Okay, so let's say we had a right angle down here, like that. And then we had another right angle, like right here, like this. Okay, so we knew that we had these two triangles with a right angle there and a right angle there. And you know, these ones aren't right angles here. So it's not a perfect square or nothing like that. It's just two of them together. And then we knew that, let's say this top side here, or this bottom side, we'll go with the bottom side, is 4.8 centimeters. Okay, and then we had this angle down here. Let's say that this angle was about 62 degrees there. And the angle up over here in the corner here, let's say that looks to be about 31 degrees. We'll go, wow, that's half of that angle. Let's go 33 degrees. Okay, I gotta make it a little bigger because it's, so we can read that a little better. We'll put it on the side here, 33 degrees. Okay, and then we want to find this side here. Let's say we want side A, B, C, D, like that. So we got, let's find AB. Okay, so this is a common side type example. We want to find the common side we want to find AC from this triangle, put it into there, and then find this side from this angle here. So find the common side. Okay, we're going to do the common side, so I'm going to do that in green here. Okay, so that's going to be opposite hypotenuse based on this ADC triangle here. So we're going to use this 30 degrees. So we've got opposite and hypotenuse. So this would be sine 32 degrees equals 4.8 over h. So AC it is, but we got an h in there. So that's okay. So we're going to multiply by h. Get rid of it. We get h sine 32 degrees equals 4.8 centimeters. Divide by our sine. 32 degrees equals, not equals, sorry, we got to divide it out. Take our calculator to do that. Okay. All right, so let's go ahead. So if you're doing sine 32, that's 0.5299. So I get my angle, my sides. 4.8 divided by 0.5299 gives me 9.06 centimeters. So that's going to be there. Okay, and then I want to find AB. So the AB, let's look at it. That's the opposite side and the hypotenuse. So it's going to be another sine value, but up to 62. So let's do that one in blue. Okay, so sine of 62 equals the opposite side over the hypotenuse, which we calculated. Okay, this one's easier, and that we just multiply 9.06 centimeters on both sides. So we've got 9.06 times sine of 62 equals our O side. Well, let's not put an O for it because people think it's 0. So we'll put opposite side. Okay, so then take your calculator and we'll get side AB. So sine 62, that's 0.8829. And I'm just going to multiply it. Okay, I get 7.99999, so we'll say 8. Okay, which is equal to side AB. Okay, so there's an example of one where you might have two triangles facing each other. So that kind of gets us through the first part of the day in terms of what about drawn triangles? Okay, let's see what we got here. We've got a fair chunk of uh, word problems as well. So I'm thinking I'll save that for next day because there's at least 1, 2, 3, or 4 different kinds of those that we can look at as well. So we're going to just do the written part today. That's about 26 minutes or so. So that'll give you plenty of time to work on some problems here. So this is on page 118. Okay, and I will give you the written ones to do, which are 3. Let's see, there's 1, 2, 3, 4 there. Okay, those ones you can do. Let's go with B and D. Okay, 4, you can do those ones, A, B, C. And 5, you can do B and, well, yeah, B and D, they're both. And 5, you can do B and D. So that gives you 7 practice ones. You got about half an hour. That should be no problem to work through those ones in the time allotted. And then we'll do word problems next day. Sorry. All right, so I'll stop there and good luck.